Today we're going to talk about compound inequalities, and all that means is more than one at the same time. So we'll start with simple inequalities, and we'll just show you how we make a compound inequality. So we have x is greater than negative 2. So remember, we're starting at negative 2, right? And we're saying that x can be any value that's bigger than that, or to the right. So it could be negative 1, it could be 0, it could be 1, it could be 2, it could be anything over to the right. It's greater than, so it's anything greater than. I'll just kind of make my arrow like that. And notice, because it's greater than, not greater than, or equal to, we make that an open circle because it can't actually be 2. It could be negative 1.9, but it can't be negative 2. All right, so now the next one, x is less than or equal to 1. So we start at 1. X could be anything less than, so it could be 0, it could be negative 1, it could be negative 2, it could be negative 3, anything over here. It could be anything over here. But it also could be 1 because that's or equal to, so we're going to fill it in this time. Okay, so those are two simple inequalities, but on the bottom now we're going to combine this into a compound equality. So in this case, x has to be greater than negative 2. So again, we're going to start at negative 2 just like we did. And it has to be greater than that, but it also has to be less than or equal to 1. So we're going to start here at 1. Again, I'm going to fill this one in because of the or equal, and it has to be less than that. So it has to be greater than that, but less than that. And you can see, so the only thing that fits are the numbers in between. So it could be 1 or 0 or negative 1 or anything up to negative 2, but not negative 2. But so that's what we mean by and. So it has to fit both of those rules. And we could write this also like this. We could say that x has to be in the middle of negative 2 and 1. And so it has to be, just get our signs right, it has to be less than or equal to 1 and greater than negative 2. So this is two ways to write it. You could write it like this, a compound inequality, or you could combine it like that. And we'll do another example over to the right. So x has to be greater than or equal to 0. So we're going to put our circle at 0, and I'm going to fill it in because it's or equal. And it has to be greater than, so it has to be anything to the right. Any value to the right would work. Now the next one, x has to be less than 1. So I'm going to do a circle at 1, not filling it in. And less than has to be anything over to the left, so just make my arrow like that. Anything less than 1 will work. But now we want to combine those into a compound inequality. So we're saying x has to be greater than or equal to 0. So again, I'm going to fill that in. And it also has to be less than 1. So I'm going to do an open circle at 1 and anything in between. That's it. It's the only space it could be. It could be like 0 or 0.1 or 0.2 or 0.9, not 1. Anything in between there is going to work. And we could write this again. X has to be in between 1 and 0. And let's just get our signs right. X has to be less than 1 or greater than or equal to 0. And that would be another way to write it. And these two things right here, this and this, are compound inequalities. And all it means is we're taking two values that we have to compare it against rather than just one. So the key word in here too is also and you'll see there's one more that we're going to deal with. Okay, but what if you see it written right away as this compound inequality? So also notice it doesn't have to say just x. So in this case, what we're saying is x plus 5 is greater than 2 and x plus 5 is less than 9. We're just putting the two statements in one. And what we can do is we can work with all three things at the same time. So this is kind of cool. And just think about when we have an inequality or an equation, we generally separate the equation along the equal or inequality sign. So we think about it as this section there, right? But now we just have two of them. So we really have three sections we're working with here. But our goal is still the same. Our goal is always to get x by itself. So I'm looking where I see the x. It's right here. I have x plus 5. I want just x. So I'm just going to subtract the 5. But what I need to do to one side, I need to do to all sides in this case. So minus 5, minus 5. And what I get is just x in the middle. 9 minus 5 is 4. And then 2 minus 5 is negative 3. And then don't forget your signs. So there and there. And so what this says is x is greater than negative 3 and x is less than 4. And we could easily graph that. So the key numbers on our graph, I'm always going to put a 0. But the key numbers on our graph are negative 3 and 4. And so now if we graph that, x has to be greater than negative 3. And I'm not filling that in because it's not or equal, and less than 4. So remember, it could be anything greater than -3, but it has to also be less than 4. And so the only things that are going to work are going to be between them, because it has to be, has to fit both of those rules. Okay, over here, one more step up, right? Again, I'm separating the problem along my inequality or equal signs. Okay, and I got to get y by itself. But before I can do that, I got to get 2y isolated, right? So I got to get rid of that 4. So I'm going to minus the 4, subtract 4 from all sides. And I'm going to get 6 is less than 2y, because the 4's are gone, right? Is less than or equal to 20 minus 4 is 20. 24 minus 4 is 20. Okay, but now I want 2y. I don't want 2y. So I'm going to divide by 2. But what I do to one part, I have to do to all. So now I'm going to get 6 divided by 2 is 3, is less than, these cancel out. Y is less than or equal to 20 divided by 2 is 10. And so now I'm just going to graph this, and my two key numbers are 3 and 10. So I have 0, 3, 10. If you notice, and I want to get rid of that right here. If you notice, I always put a 0. I like to kind of anchor my line with the 0. But anyway, the two key parts are 3 and 10. So notice, I'm going to have to be, I'm not going to fill this in because it's not or equal to. And y has to be something bigger than 3. But it also has to be less than or equal to. I'm filling it in because it's or equal to. Less than or equal to, so it has to go this way. So it has to be in between there, okay? And so y has to be greater than 3, and it has to be less than or equal to 10, and that's how it would look like on a graph. Okay, there's one other type of compound inequality, and that's or. So let's graph these two things separately, and you'll notice we're not going to combine these into that one sentence, and you'll see why in a second, okay? But our two key numbers here, x has to be less than 0, or it has to be greater than or equal to 2. And you'll see why this looks different when we graph it. So I have 0, and I have 2. Those are my two key numbers. I can fill in the 1 if I want. Maybe I'll even do a -1 and a 3, okay? But the first rule is that x has to be less than 0. So open circle 0. And less than would be -1, -2, any of these numbers, right? So anything over here is going to work. Or x could be greater than or equal to 2. So I'm filling in the circle of 2. But greater than or equal to means anything to the right. It could be 3, it could be 4, it could be anything over here. So anything over there is going to work. And so notice it's not the numbers in between. It's the numbers on one side or the other. That's why it's or, right? Or means it's on one side or the other. And so when you see or, you immediately should think it's these two parts that are split. Whereas and should make you think it's going to be the area between two numbers. And we'll see that again here. And this is just a reminder of the one key rule. When we're dealing with inequalities, I'm going to write it out. Remember, if you multiply or divide, so multiply or divide by a negative number, you have to flip the sign. Okay, so write that down. Keep that in mind. That's the only catch. Everything else should be pretty straightforward, but there's that one catch when we're doing inequalities. So in this case, I don't want the 4m, the -4m. I just want m. So I'm going to divide by -4 to both sides. And when I do that, I'm going to get m. And then 1 divided by 4, negative divided by negative is positive. So 1 divided by 4, I'm just leave that as 1/4. That's fine. I could say 0.25. But instead of less than or equal to 1, now it's going to be greater than or equal. Notice, again, let me get a different color so it stands out. Notice it was less than or equal to, and now it's greater than or equal to. Okay, we flipped the sign because we divided by a -4. Okay, it doesn't matter what, it doesn't matter that this like -1 is a negative. It's what you divide or multiply by. Okay, and we're going to do it again to the other side. So I want to get just m, right? So I'm divided by -4, divide by -4. And so this is going to cancel out. I get m. And 16 divided by 4 is 4, but it's going to be -4. And again, my sign, let me get that color again. It was greater than or equal to, so now it's going to be less than or equal to. So now when we graph this, I'll have 0. My two key numbers are 1/4, so it's like 1/4. I'm just actually going to put it as 0.25, right? And then we could say We'll do 1 is here. We'll do 2. Okay, but now we got to go to -4. So -1, -2, -3, -4. And so m has to be greater than or equal to a quarter. So fill it in because it's or equal. And it has to be anything greater than. It's over to the right. Anything over here is going to work. If it's 1, if it's 2, if it's 3, if it's a million. But it also could be, or it could be less than or equal to -4. So filling this in again. And less than is anything to the left. So the arrow go there. And again, or means it could be over here or it could be over there.